Hi everyone, and welcome to our video on factoring completely. So far in this unit, we've learned some different techniques for factoring. We've learned how to factor by the GCF. We've learned how to factor trinomials of the form ax squared plus bx plus c when a is 1. We most recently factored the difference of two perfect squares. And today we're going to do what's called factoring completely. And that pretty much means you're going to combine everything you've learned so far. So I want to go ahead and read this first paragraph to you. When you are first presented with a polynomial to factor, check for a greatest common factor. You should always do that first because in a lot of cases that will simplify your polynomial and make it a lot easier to see if there's any further breaking down you can do. After factoring out the greatest common factor, examine the polynomial that remains. Try to factor this polynomial into the product of two other polynomials. So I've got 4 examples here that we're going to try today. So let's just take a look at our first example. We're supposed to factor the polynomial, the trinomial, 2m squared plus 30m plus 108. Okay, so we want to look for a GCF first. Now, on the TI-84, I've shown you how to make finding a GCF quicker. So I'll show you that again. So if we press Math, Num, and then the number 9, the calculator calls it GCD, and we can type in our 2 and our 30. Now remember, we can only do 2 numbers at a time. So the GCF of a 2 and a 30 is a 2. Now I'll take, oh, sorry, you can hardly see that in the light there, is a 2. Now if I do this again, Math, Num, 9, and I use this answer, 2, comma, and then my final number here, 108, you can see that the numerical part of my GCF is a 2. Now, that's one way to do it. Some of you don't like using the TI-84 for such things because you're confident and know you want to do it in your head. So if you want to do that, you could say to yourself, okay, what is the biggest number that goes into or is a factor of 2, 30, and 108? And that would be 2 because 2 goes into 2, 2 goes into 30, and 2 goes into 108. And if you can't see that and you still want to do it by hand, you can certainly break down a 2 into its factors, which would just be 2 times 1. You can break a 30 down into its factors, which we could do 10 and 3. And 10 can break down to 2 and 5, all primes. These are the prime factors. And let's see, 108 we could break down to 54 times 2. That's the first one I think of. And I can break 54 down to 27 times 2. And I can break 27 down to 9 times 3. And I can break down 9 to 3 times 3. So looking at each one of these terms individually, this is what I've got. And I'm going to now include my m's as well. So the 2 would be 2 times 1 times m times m. That's my m squared. My 30 would be, where was I here? 253, so 2 times 5 times 3 times m. And finally, my 108, get ready, 3 times 3 times 3 times 2 times 2. 3 times 3 times 3 times 2 times 2. And the 108 doesn't have any m's. Now, when I look here, I have to find what's common, the greatest common factor. Well, I definitely see a 2 in every box here. And that is about it. And so that just verifies again that my GCF is 2. See, the 108 doesn't have any m's, so I can't include any m's. And if you think about the shortcut we've been using for GCF, we always said, take the numerical part, of course, and then for the variables, factors get fewer, factors go down and get less than the original number. So we want the fewest amount of m's in any one term, and the fewest amount is none. Okay, so we've got the GCF, and this is the only one I'll go through all this with. We've done this before, I just wanted to remind you. And now we take our GCF to the front and we rewrite on the inside here what remains. We're writing this as a product of the polynomial's factors, two other polynomials. So we divide each of these terms by the GCF, which is 2. And whatever that result is what goes in the parentheses. So 2m squared divided by 2, those 2's cancel, is just m squared, plus 30m divided by 2. Well, 2 goes into 30 15 times, so we'll say 15m. And then 2 goes into 108 54 times. So we've written this as a product of polynomials. Now we're to examine. It says examine the polynomial that remains right here. This is a trinomial, and it's in that form ax squared plus bx plus c. It's just we're using m's. So we're going to try to factor this. So let's see if we can go a little bit further here. When we factor a trinomial where a is 1, we know that we factor down to m and m because that first distribution is going to give us that m squared. So then I need two numbers whose product is 54, but whose sum is 15. So let's see if we can think of anything. The product of the two numbers is 54, but the sum, that's addition, is 15. So you may have to think on that for a little bit, and hopefully you'll come up with, even if you pause this, 9 times 6. 9 times 6 is 54, but 9 plus 6 is 15, so that's the magic. So I'm going to add a 9 and add a 6. And you can see that there's my m squared, here's my 6m, here's my 9m. So 6m plus 9m gives me my 15m, and then there's my 54. So final answer to this first example, 2 times the quantity m plus 9 times the quantity m plus 6. This is written as a product of other polynomials, and that's the final answer. We can't go any further with that. Okay, let's go to example 2. We'll speed this up a little bit. Okay, so here we have 4x squared minus 44x plus 96. So the first thing we're going to do is look for a GCF. If you want to do it by hand, feel free. If you want to use the TI, then off we go. So we've got math num 9. We'll start with a 4, 44, and that's 4. We'll do it all over again with the 4 here and 96. And so it's 4. So the largest number that divides into or is a factor of, the largest factor of a 4, a 44, and a 96 is 4. And they don't have an x all in common because the 96 doesn't have any x's. So I can't include any variables in my GCF. Now let me divide each term by 4. And so that's going to give me x squared minus 11x plus, what's 96 divided by 4? 24. Okay, so there is my first step with a GCF out. Now I'm going to see if this trinomial will go any further. So I'm going to put my x's in because I know that first distribution is going to give me that x squared. So now I need two numbers whose product is 24 and whose sum is negative 11. Two numbers whose product is 24 and the sum is negative 11. So I'm thinking 8 and 3, or something about an 8 and a 3, because 8 plus 3 is positive 11 and 8 times 3 is 24. So now I just have to tweak the signs. In order to get an 8 and a 3 to add to negative 11, they would both have to be negative. Now, if they're both negative up here, a negative times a negative still gives me that positive 24. So those are my two numbers, negative 8 negative 3. Let's see if it checks out. We've got the x squared. Here's the negative 3x and the negative 8x, which adds to the middle, negative 11x. And here's my negative times my negative, giving me that 24 on the back. And so we've got it. There's our final factored answer. Okay, let's check out example 3. Factor 5p squared minus 320. So now we just have a binomial. Works the same way though. Let's find the GCF. So again, you can do it by hand or you can make it faster. Math num 9. We've got a 5 and a 320. So it's 5. So pull that 5 to the front as our GCF. Unfortunately, 320 doesn't have any p's, so the lowest number of p's in any term is none. So we'll just stop right there. We'll divide each term by 5. That's going to give me p squared minus, let's see, what's 320 divided by 5? 64. All right, now I'm examining what remains, and what I'm seeing is a difference, remember this lesson, of 2 perfect squares. So we have to think back to a squared minus b squared, factoring into the quantity a plus b times the quantity a minus b. So if we write this as p squared minus 8 squared, then we've identified a and b. And so the final answer will be the 5, and then a p plus 8 and a p minus 8. And we did a really good lesson on that in a previous video, so check back on that if you've forgotten difference of squares. You can check it, of course, because here is your p squared. Here's your negative 8p and your positive 8p, which make that middle term 0. And right there's your negative 64. Excellent. And here comes our last one. 4bc squared plus 12bc minus 40b. Okay, let's try a GCF first. So we'll do math num 9. What are our first two coefficients? 4 and 12. And I think that's going to be a 4. Yep. And then a 4 and a 40. I think that's going to be 4 as well. 4 and 40. Yep, 4. So the largest factor of any of these terms that is similar is 4. Okay, now let's look at our variables. So we've got a b and a b and a b. So all three of these terms have a b in common. Here we have a c squared, a c, but no c here. So the lowest amount is none, so no c's in our GCF. Okay, let's divide each of these terms by our greatest common factor, which is 4b. And let's see what we get. So the 4's here will cancel. The b's here will cancel, and I'll just be left with c squared. Here, 4 goes into 12 3 times. The b's cancel, so I'm just left with 3c. Minus 4 goes into 40 10 times, and these b's cancel, so 10. Now I'm examining this polynomial, and I'm thinking that it may factor. I know I'm going to put my two c's here and here. And now I need two numbers whose product is negative 10, but whose sum is 3. So I'm thinking about a 5 and a 2. Now, I got to do some sign tweaking here. In order to get a product that's negative, only one of these may be negative. So if only one of these may be negative, which one does it have to be to add them to a positive 3? Well, the negative 2 would have to, or the 2 would have to be negative, because 5 plus negative 2 is positive 3, and 5 times negative 2 is negative 10. So there we have it. So it's going to be c plus 5, positive 5, with a negative 2. Final answer. And if you check it, it will work out and bring you back here. All right, factoring completely. Thanks for watching.